Hello everyone, this is Ian Draney with a video presentation for Engineering 465 at Oregon Institute of Technology, capstone project, fall 2017, and this is to go over the Bluetooth trainer and Bluetooth drum pad in a video series, two-part video series, this video being part 1 of 2. Here are the electronic components of the Bluetooth drum pad that is opened up, so you can see the Arduino microcontroller, battery pack, a couple of connected switches, perf board with soldered on components, and the HC05 Bluetooth module. And on this side, this is a piezo disc which collects the analog signal. And you see that everything is connected here, or at least for our analog and digital signals that I want to show to you today, are connected to the Analog Discovery 2 oscilloscope. And the first part of this, I want to gather some samples to show the conversion from an analog signal, which inputs into the microcontroller, and the output of a digital signal, a set of digital signals, to the Bluetooth controller. So what I will do here, actually show you the oscilloscope here, which is currently running. What I'm going to do is tap on the device so that the piezo resonates, sends a voltage signal to the microcontroller, and then outputs the serial data to the Bluetooth controller. Okay, so I will begin tapping as we watch the oscilloscope. And we see that the yellow line, and I'm actually, so I can keep talking, I'm going to grab one single signal. And we see that the yellow line is the analog signal. Produces up to 5 volts input into the Arduino microcontroller, and then we see that the blue line is a series of digital data sent over serial output from the microcontroller to the Bluetooth module, which then is received by the Android app, which will be shown in part 2 of this series. Okay. What I'm going to do is zoom in just so we can see a little more granularity of what happens to the, I guess, the conversion here. And this is pretty good. Usually I take another sample so we get a little more granularity on the digital signal, but this turned out pretty good. And you see that the digital signal is normally high, and then it sends a low signal and a series of bits, depending on the sampling time, which takes about a 2 millisecond delay, 1 to 2 milliseconds. You can see that it goes low. The digital signal goes low, which is the start bit, and then a progression of numbers 0 to 9. That progress through this signal. If we were to decode this, we would see that from the least significant bit to the most significant bit is displayed, and then has a stop bit of 2 ones, and then of course a start bit for the next number of a 0, which is then the next number is shown. That repeats until we reach the end, where the signal goes high again, when the microcontroller is ready to output the next number. And I think that should wrap it up for part 1 of this part 2 series, analog digital conversion. And in the next video we will show the Android app receiving the serial data. Thank you very much.